Hello everyone, welcome to CAE for you. In this video, we will show you how to download OpenRadioss binary files, install the GUI to launch the case files and run sample simulation, view the result in Paraview, and we will do this in Ubuntu 20.04. In your web browser, search for OpenRadioss. It will take you to the home page of OpenRadioss software. Scroll down till you find the link download. Click on the link. It will take you to a GitHub page. Since we will be working on Linux files, we will click on OpenRadioss linux64.zip link. Once you click, the download will start. OpenRadioss is a free FEA software to analyze highly dynamic phenomena. It uses the same input format and the source code of commercial software Radioss from Altair. Additionally, the software is also capable of running LSDyna DEC files. Both Radioss and LSDyna are industry standard FEA softwares, so we can expect that using OpenRadioss we will be able to run industry quality FEA simulations. The download is complete. Let us go back to the OpenRadioss web page and navigate to more info option. Clicking it will take you to a page from which we can download the GUI to launch OpenRadioss. Once the web page opens, navigate to running OpenRadioss and click on Python GUI. It will take you to the page from where you can download the GUI scripts. It is recommended to click on the latest GUI script. Once you click the link, it will take you to the page from where you can download the GUI scripts. You will find scripts for various platforms. You can choose Linux GUI script zip download. The script has been downloaded. The script runs using Python TK. So first you can check if Python has been installed. Then you are all set to install Python TK. It can be installed using the command sudo apt-get install python 3-tk. You can issue this command to ensure that the TK has been properly installed. Once it is installed, we can configure the environment variable and launch the GUI script. Since we have already done this step, we will skip it. To get the environment variables, let us go back to the OpenRadioss page. Locate the GitHub link, click on it. It will take you to OpenRadioss GitHub page. You can just scroll down to find how to use OpenRadioss. Under this section you will find a link how to run OpenRadioss. You click on the link. It will take you to a section of how to run OpenRadioss, in which you will be able to find out the environment variable settings for Linux. Copy the settings into any of your text pad. We will come back to the settings of environment variables bit later. We will try to download some of the sample input decks to check if the installation has been done properly. Of course, OpenRadioss portal has some pre-built cases. We will go to the OpenRadioss page and click the more information as we have done before. Now under the section example models, we can find LSDyna input deck. We will select the tensile test case, click on the link. It will take you to the model description, and also it will contain the model data file. You can download the LSDyna input deck file by clicking on model file. Now let us move the downloaded zip files into a convenient location. Once you move all the zip folders, unzip them. You can just right click and extract here can also be used to extract the zip file folder contents. It is important that the file path locations are correctly specified so that the configuration file is able to locate all the relevant files. In Linux window, you can press Ctrl L to display the complete path of the file, which you can copy and use it to locate the OpenRadioss files. You can also double check if the configuration path and H3D path are consistent with the OpenRadioss path that you have just copied. This will ensure that the files gets launched without any trouble. Another important aspect is to check if the execution permission is available for all executable files. You need to ensure that the executable permission is checked in, not only for the binaries but also for the bash script. As you see, currently the execution permission is not provided, so we check the execution permission to ensure that the script gets executed. We notice that the folder location and the path specification is inconsistent, so we make the necessary corrections in terms of moving the folders to the correct path so that the software identifies the folder locations, and also we ensure that the script folder is also placed along with the OpenRadioss folder so that the script can be launched without any problem. We will create a work folder and move the LSDyna deck folder into the working folder, and then we will unzip the zip file so that we get the deck. We can just open the deck file in a text pad in order to review how the input deck looks like. This seems to be created using hypermesh. Now we are all set to launch the script. To launch the script, navigate to the folder Linux scripts mk3. Open a terminal from the folder, active folder. Then you can type Python 3 OpenRadioss. Here you can just press tab for auto completion. You will be able to get the Python script which needs to be run to get the GUI. Just press enter. You will be able to see the Launch GUI. Now you can navigate to the working folder and locate the .k file, which is the lsdyna.dec file, and in -nt, that is number of threads, you can fill in 4. Then you just press add to queue. You will be able to see that the job has been added to the queue and it is running. So all went well. So we were able to run the simulation. Once the simulation is completed, we will be able to find the .vtk files. Of course, I missed to tell that you have to check anim and .vtk conversion and CSV checkbox, so that we will be able to get the .vtk file and the CSV file to view the results in Paraview. Now the results file has been generated. Now let us open Paraview, navigate to the working folder. We will be able to see the .vtk group. We just open it and click apply. We were able to see the results. Then we can see there are a lot of output values that are present. Now we will choose the displacement value. We will readjust the legend and then press the play sign. We see that the simulation has been run well and the result seems to be as intended. So now we were able to view the results successfully, but we also noticed that as we see the surfaces with or the grids, we notice that some elements seems to be abnormally deforming. Of course, there are a lot of scope to debug and check why some portion of the result appears different, but it should be noted that we are not running the native Radioss file format, rather we are running lsdyna file. However, we still feel that OpenRadioss can be a very nice addition to the open source software community in terms of expanding the capabilities to perform industry standard simulations. Hope you liked our video. We will catch up in the next one.